All right, everyone, let's get the show started. Welcome to Office Hours. It's February 26th, 2020. My name is Eric Osterman, and I'm going to be leading the conversation. I'm the CEO and founder of Cloud Posse. We are a DevOps accelerator. We help startups own their infrastructure in record time by building it for you and then showing you the ropes. For those of you new to the call, the format is very informal. My goal is to get your questions answered. So feel free to unmute yourself at any time if you want to jump in and participate. If you're tuning in from our podcast or YouTube channel, you can register for these live and interactive sessions by going to cloudposse.com/office hours. Again, that's cloudposse.com/office hours. We host these calls every week. We'll automatically post a video of this recording to the Office Hours channel, as well as follow up with an email so you can share it with your team. If you want to share something in private, that's okay. Just ask and we'll temporarily suspend the recording. With that said, let's kick it off. So I have only two talking points today, one of which we had has been on the docket for the last few weeks. We never got to, and one new one, which are some practical tricks for change management. Igor on the Slack team asked about this week, so I thought I'd just jot some notes down. This is a draft. This is not finalized, but these are just some of the things that we do when we work on our engagements with customers. So with that said, I'm going to turn it over to everyone who's attending. Are there any questions you guys have related to Terraform, Kubernetes, Cloud Posse, DevOps? You name it.
Maybe me?
All right, go for it.
I mean, can I ask you like anything actually, or like this? I mean,
more or less. I mean, let's try and keep it topical to what we do here, on Sweet Ops. But yeah.
Okay. Yeah. Thank you very much. So actually, the reason I cross Sweet Ops is because I was Googling these questions, and like your website is quite well positioned on Google, so here I am. And what I was looking for is like, what are the like if there is any tool out there that can help with automation of software deployment to IoT devices. Like for example, let's say like I have like 1,000 devices out there, all of them with software like. For example, like a couple of repositories on GitLab, and it's a bit of chaotic to keep all those devices in the same state. Like I'm always running old versions of different software because the devices go offline and then go online again. What I have right now is I have an Ansible playbook running continuously on a loop, which is not very efficient. I believe there must be tools out there that can make this easy, or maybe they can provide some kind of dashboard or graphic interface that can help me keep track of it. And like there are so many tools out there, and I have no idea like what can be better than my incredible Ansible loop.
That's a good question. So just to recap what you said, basically you're looking to learn what are some of the strategies for managing deployments at IoT scale across lots of devices. And to date, you've just been using Ansible in a continuous loop. So IoT is not a specialty that we have at Cloud Posse, so I can't really speak to that. I do know that Amazon has some offerings specific to IoT, and I believe just recently they announced another offering related to IoT and deployments. It was just this past week or something, I think. I'd have to look it up. But maybe there are people on the channel here who have other insights. Anyone else here doing IoT deployments or any armchair commentary?
I'm not doing, I'll turn my video on. I'm not doing IoT deployments right now, but I did interview at a company that had hundreds of thousands of devices doing energy monitoring. They wrote everything from scratch and had all of their IoT devices polling for updates. So it's a very interesting like metrics system, because you'd get partially things that hadn't checked in a while, like pop back up on and then be really old and have to get updates. So they always had to maintain some update process from older stuff to like from their first initial stuff to the latest. They ran into problems with that. They built all of their code in Go. So it was a single binary that would get shipped. And I can't remember exactly their process for shipping it, but yeah, unlike, maybe it's just because people have there's a lot of different chips, you know, embedded systems is very, I don't know, like Androided, diverse operating system. It's something that every company seems to do a little bit differently, but I would definitely check out the AWS, like the cloud offerings for like their IoT edge gateway type stuff, and see if there's any documentation on how they like the getting started tutorials there. Can I ask, what is your IoT system? Like, what are the devices doing, and how complex is the infrastructure?
Yeah, thanks for your answer. So our system is very similar to what you described before. So we have energy management monitoring systems. We have devices receiving data from sensors, and all this data is sent to our platform hosted on AWS. Basically, that's what it does. But yeah, we we keep all these devices connected through different networking possibilities. It can be LTE, 4G, 3G, or Ethernet, or Wi-Fi. And because these devices are placed on factories, sometimes these factories are in remote areas in mountains somewhere, so they don't have internet connection. And it's very likely that they only connect once a day. And this is why I need to look for a solution that is gonna realize when those devices are again online and deploy there. And sometimes this Ansible never-ending loop is not fast enough to pick up those devices.
You also have to be worried about like what happens if you brick the device, right? That's always the thing I'm so impressed about with things like I run Sonos, for example, at home. Imagine if they send out some update that bricks, 2 million devices. Oh my God.
Yeah, I've broke a couple of devices already. So we have to go there to those mountains and actually replace them. But now it doesn't happen anymore, so I'm happy about that. But yeah, I know what you mean.
Herrera, did you join the SuiteOps Slack team?
Are you asking me? Or?
Yeah.
Yes.
Okay. Are you in the office hours channel? I didn't know what your Slack username was, I guess, so it didn't work. But make sure if you're in the office hours channel, you'll see the link that I just shared there, which was what I was thinking of at least, but no experience with it.
Okay. Yeah, I just saw the link. Thanks for sharing.
Yeah. Cool. All right. Any other questions from anyone?
I have a question that I posted in the Docker channel yesterday about.
Oh, okay. Let's see.
Yeah, it's basically about I see Docker D just like eating up all our memory, especially when we don't run deploys very frequently. And we're using the version of Docker that is in Amazon's Yum repository. I don't know if that is different to the mainline version of Docker. But yeah, there seems to be some sort of memory leak. We don't think it's coming from our services because it's Docker D that ends up eating up all the memory. So yeah, I don't know if anyone has any experience with that.
Yeah, anybody seeing Docker D memory leaks lately? Just yeah, here's the message in the Slack team. It seems to scale with the number of requests that they're receiving to the Docker daemon.
I mean, like it seems to scale with the number of requests received to our services, right?
Oh, gotcha.
So that's why I think it's something like log related, because we log to standard out and then pipe those logs elsewhere.
Yeah. And you don't see it recover? So it couldn't just be a buffering thing?
No, it just goes up and up until we restart Docker D, basically.
What so from first-hand experience, the up and up thing is sometimes still up and up to a point, and then it will recover. Like with Prometheus, we thought there was a memory leak, but it turned out that it needed in our case it needed a minimum of 12 gigs of memory, but we set our limits. What we thought was still pretty high. So
interesting.
So maybe it's just not, maybe it seems like a leak, but it's not high enough.
Yeah, I guess so. It just has this interesting behavior of like when we do redeploy, like it drops down dramatically and then kind of creeps back up and up and up.
When you redeploy the Docker daemon itself, though,
Yeah,
you would like to
exactly.
know, yeah, so it starts off, yeah, no firsthand account, just gut says that maybe it's probably not a leak and just buffering.
Okay, cool.
But, all right, any other questions?
Yeah, Eric, this is Hari, and we have a different kind of scenario where we use a common environment files between multiple deployments. So we are trying to find out the best solution to share that common environment file between multiple projects, in fact.
Yeah, certainly. I mean, I'm sure there are a lot of ways you can solve this, and I don't know about your specific use cases, but I mean, when you're saying environment files, you're actually like files that have environment variables in them, right?
That's correct, yes.
Yeah. So, so the good thing there is your applications themselves support environment variables. Now we just want to maybe consider an alternative interface for passing those settings with environment variables. Are you familiar with a tool called Chamber by Segment.io?
No, this is new for me.
Yeah, so this is a great little tool to be aware of. Are you on Amazon by any chance, AWS, or using a different cloud provider?
No, we don't use AWS.
Okay, sorry. So my advice here is, okay, so this particular tool I was going to recommend doesn't really apply to what you're doing. But the pattern translates to another tool I'm going to share in a second. So just for everyone else's sake, I'm just going to explain in 30 seconds what Chamber is if you're not familiar with that. So Chamber is a CLI tool. It's written in Go, so you can download a single binary. And what you do is when you call Chamber, you pass it the SSM like service or SSM namespace for your environment variables, like production. Okay, no, sorry, this is exec. This is not Chamber. Here, like, where's Chamber being used? Chamber exec. So you see, you call Chamber exec and the service name and then your command, and then it'll export all those environment variables from that service. But you can have any number of services there just listed, separated by spaces, and it'll concatenate or it'll merge those service namespaces and the environment variables therein into one, overriding them in order. This will help you. So basically, if you defined a service namespace for your apps, you could then very easily share environment variables between them. So you said that you're not using AWS. Is this bare metal or are you using a different cloud?
We use Oracle Cloud.
Okay, which cloud? What provider?
Oracle provider.
Oracle. Okay, yeah. So yeah, that's definitely outside of our wheelhouse. But if you're using HashiCorp, do you guys have HashiCorp Vault?
No, we haven't started using it.
Do you have Console? So
No.
Console by HashiCorp?
Actually, the the one that what we are using is we are mounting. We are creating a persistent volumes, and inside that we are keeping this file, and we are mounting inside the container as a mount path. Okay, and then we are using a shell command to sourcing as environment variables.
Yeah. So, I mean, that's certainly a common way of doing it, is having a shared file system like that. But I mean, it does put a lot of, it makes that file system your central point of failure, and traditionally scaling the storage is, and the IO on that could be, or the availability on that could be trickier. So Console is used for service discovery, but also basically sharing configuration or settings in a highly available manner. I believe it uses the Raft protocol for consensus. It's relatively easy to deploy. It's very common in enterprise and other kind of settings. If you don't have console today, it sounds like that might be a gap actually in what you guys are running. The reason why I bring up console is that if you use console together with a tool called env console, you can achieve the same outcome as you can with the chamber command I was telling you. So with env console, you can have these shared settings that are distributed in this highly available distributed key value store of console, and then expose those as environment variables to your commands.
Oh.
So it's not exactly maybe the answer you were looking for. I mean, if you're going with the NFS route, I would just generally avoid the NFS route if you can from a best practices perspective until.
Yeah.
I guess I have a related question then. If we were to use Chamber, how would you get those secrets into like running Terraform?
Oh yeah, so well, you have two options. That's a great question that you ask. I'll give you two options for using Chamber with Terraform. I'll show you kind of the progression that we've taken at Cloud Posse, because we also learn what works and what doesn't. So for the longest time, what we were doing is just setting all those settings in Chamber as SSM parameters. So let's see if we go back to Chamber. So Terraform supports the use of environment variables for setting the values of Terraform variables. But there's one annoying thing that Terraform does. So Terraform requires that Terraform variables look like, let me go to a window here. All right, so if we were using Terraform, for example, you'd say like export tf-var foobar equals 1, 2, 3. And now foobar will be available if I call Terraform plan or something like that. So if when you're using Chamber, you write Chamber write tf-var foobar 1, 2, 3, then you can now call Chamber exec. I did this slightly wrong. It's going to be Chamber write my namespace. So let's say prod, and then tf-var foobar, and then I think it's 1, 2, 3. I might get the syntax slightly wrong, but you get the gist. And then Chamber exec prod Terraform plan. What this is going to do is it's going to fetch the variables from the prod service namespace and export them before I call Terraform plan. Now, one thing to be aware of with Chamber is that it automatically normalizes the case of everything. So actually what happens is these things become tf-var foobar, which means that in your variables file in Terraform, what you would have is like variable foobar. Typically, you would have something like this. And this is lowercase. Well, if you're using Chamber, here's the thing that sucks. You got to call this uppercase foobar. But there are two ways of looking at this. One is that it makes it very clear that you expect this to be set as an environment variable, and uppercase environment variables is more or less a standardized convention. So that's one way of looking at it. But so at Cloud Posse, I didn't like that too much. So we wrote a small little utility called tfenv. Tfenv is not a version manager. Tfenv works like the env command, and tfenv will re-export all these environment variables in a way that is consumable by Terraform. So I'm just presenting this as an alternative way. So if you're using tfenv, you can use it together with Chamber and then pass the environment variables. All right, I'm happy to go into more details on this. This was a little bit hand-wavy, But the reason why I want to kind of skip over it is I want to point out that if you're using Chamber and you're using Terraform, there's almost no reason to use them together at the same time. And let me explain. So all Chamber is doing is reading and writing settings to SSM. Well, Terraform supports SSM natively. So if you use the Terraform AWS SSM provider, or not provider, resource, you can just fetch those parameters directly from SSM. So here's an example of reading a parameter named foo from SSM. If you do this, so basically what we're describing is something similar to what could be achieved with remote state, right, in Terraform, where you're pulling the outputs from some other plan or some other process. But the difference is because it's an SSM, it's usable by all kinds of services, not just Terraform. So of those two solutions presented, is there one you'd like to know more about, or was that sufficient detail?
I think that's a great starting off point. Thank you, Eric.
Okay, sure. We also, it's a little bit out of date, but Posse Chamber. If you just search our docs, we have kind of how we use Chamber here. It's more or less current, but because the interface to Chamber hasn't changed too much, but we explain a lot more of this here. All right. Any other questions I can help out with from anyone?
I can ask something that I probably already have part of an answer to, but you know, extra validation might be good.
Yeah, sure.
So we just had a conversation on our team about secrets. So we've recently started to put secrets in Vault, related to a previous question here. And we recently deployed a whole bunch of stuff in Helm, and then got upset with Helm and pulled the Helm out, and are now deploying our own stuff via Customize, and then other people's stuff via Helm. That seems to be working in an okay fashion.
Okay.
We've got Argo CD shipping those, which is pretty sweet. I really like what we've done with Argo so far. Thanks for the help in previous questions related to that. But our the way that different applications want secrets is some need them as environment variables, others need them as a mounted volume, and others we've like injected them into environment variables, not like through the, so we have 3 different paradigms for injecting secrets out of Vault.
Yeah.
There's some, so what I wanted to ask the group is sort of like, okay, in those 3 situations, what are the bad things that I can do so I can write best practices? Like, for example, we just changed a bunch of our mounted secrets volumes, which are, I think, my current preferred version, to have them in memory instead of on disk. I forget the weird incantation that you put something : memory in to get your mounted volumes to be in memory, but like, is that better in memory or worse in memory? And like, how else can I make it harder for people who've maybe broken into Kubernetes or like found an exploit in Kubernetes that's not published, and like make it at least a little harder for them to get the crown jewels of our kingdom?
Yeah, any opinions? Anyone? Is Andrew Roth on the call? No, he's not today. Yeah, so I'll chime in. Yeah, I think first to recap kind of your question here is that you bring up a good point that we talk often about secrets management, and like there's kind of like a canonical way of doing it, but you're really ultimately at the mercy of the applications you use. So if you're using some Helm chart, you're at the mercy of how that Helm chart was written, how it wants to manage its secrets. Or if you have your own custom-built in-house applications, you have pretty much every option available to you because you are in control of how that should work. Sometimes apps support environment variables, sometimes apps support configuration files. So the reality of secrets management is that one size does not fit all in the reality of integrating lots of different software. So I think that what we should think about is prioritizing what you're doing for your internal apps and then going down from there. The other consideration with all of this is local development. Like, one can create some pretty robust solutions for managing secrets, but it's also going to complicate how you're writing that code or using that code perhaps for local development. And when I say that, it's kind of pointing to native bindings to AWS, sorry, not AWS, to HashiCorp Vault and to like ASM, Amazon Secrets Manager. So if you're making your app natively talking to these, I think on the one side, you're getting a better, more secure application, but you're also vendor locking and making it harder to develop those things locally versus using environment variables or perhaps a config file format.
Yeah, that's a very valid point.
Go on.
I just locked there we go, back, sorry. One thing that I've seen done is to give every developer access to like a development namespace with some dummy stuff. So when you do a Helm deploy in a specific environment of certain things, then you can pull secrets from dev in the same way on your Minikube cluster that you would in an Amazon EKS cluster from your prod Vault namespace. It's going to be a lot of tooling to get that to work smoothly. But that is what I guess our team is doing right now. I don't know if it would scale to the whole engineering team. And then like a lot of the other apps, we have like a separate kind of branch, like non-production-esque branch of how do you run local development. Right now, that's like Docker Compose file that has a file that gets put in the right place, and the app is happy with that. But we've got a lot of fragmentation because things are done differently across different microservices, which is concerning to me. So. Yeah, and then the downside of, I think, putting it as environment variables is if you inspect a container, you can get most of those.
You can, which is a downside. So, I mean, environment variables are not the most secure. They're just the most portable.
Yeah, but which is, you're always weighing pros and cons.
Right.
I mean, maybe, so I guess, let me rephrase that question. So it sounds like you prefer environment variables over mounted on disk for portability, which is
I have, and I've also been on calls with SecOps teams, which bring up exactly the point you talk about. Like, environment variables are a best practice of the 12-factor pattern, but the 12-factor pattern is not necessarily a best practice for security.
Right.
So these things can be at odds with each other.
So I suspect since you're running a few more Kubernetes clusters than we are, that you've also thought about other SecOps pieces of that. We don't really have, I mean, we send logs to New Relic and logs to Splunk and metrics to New Relic, to my dismay of open source, lack of open source in there. And we've got some metrics on various different things, so if weird stuff happens to the cluster. But what are you doing to make it harder for somebody to break in and inspect a container, or do you have any sort of basic like recommendations for somebody wanting to just in general secure not only the secrets, but their cluster in general?
I don't think I have the answer that you want to hear per se.
I got one.
But okay, you fire away. Was that Dale or?
Yes, it's Dale.
Awesome. Go for it.
All right. So there is Falco, which is a part of the CNCF tool base.
What was it called again? One more time.
It's called Falco.
Falco. Yes.
Yeah. So that monitors like runtime.
Do you run Sysdig or Falco or other stuff?
We're getting into it, not quite there yet. Currently, we actually use Twistlock that actually does the same thing at runtime, and as well as like with scanning images and within our CI. But Falco is the open source version of actually achieving that.
So Falco, let me brush my memory up. Too many things that I can't remember. Like process tree analysis is something that I could trigger a Falco alert off of.
Yes. That's right.
So you said you're getting started with it. Tell me about that process. How much time have you invested in deploying the open source tool? Did you look at just giving Sysdig a pile of money to use their stuff, which gives you some of that for free? What do you?
No.
No.
Yeah, so we're trying to get away from actually spending more money in that, and just replace Twistlock with something pretty much similar. I've actually looked at a few demo and well, not a lot of time has been invested really at this point. Going to look see in March to actually make that investment towards it. I can actually find and post one of the presentations that were given.
One second, Dale. It's a little hard to hear you. Are you far from your microphone or?
Yeah. I keep thinking I can talk to the screen and you can hear me, but no, that's not the case.
Much better. Yeah.
Yeah.
Loud and clear right now.
Cool. Yeah. So I can post a link to one of the conference talks in terms of how Falco was used to actually manage and help to evade any intruders to containers. So that's one thing. But in terms of an actual POC, I haven't actually got around to that as yet.
Cool. Yeah, it's been a while since I looked at Falco. I worked at a much larger company than I'm at now that courted Sysdig for a while, and we deployed that whole infrastructure as a POC. I don't know if we ended up engaging with them, but I love working with that team. They're all really smart engineers. There is, similar to HashiCorp and many other companies, they've got like a bunch of their stuff open sourced, and then you hit this cliff, and if you want the rest of the features, you have to pay, which is totally fine. But I haven't found anybody that's using Falco in a purely open source fashion and being really happy with it. But I would love to look into that at some time.
Actually, related to this, Mahesh asked earlier today about something kind of related, which was about ways to lock down. Like, is there a way without RBAC to lock down the ability to exec into a pod? Other than maybe eliminating shell altogether. That's probably the right answer right there.
I was gonna, but even then you can attach to a running process with kubectl attach something or other and do something there. Can't remember how. But yeah, exactly.
I'm not familiar with attach. What does does that attaches you to that process's console, the running process console?
Let me not fail at answering this question and instead just post a Stack Overflow post, and then read my own Stack Overflow post that I just linked to. Interactive container. So maybe you still need a shell to attach. Uncertain. I will try at some point to remove bash and then see, or remove all the shells and see if I can attach. You'd have a tough time running anything without.
A lot, yeah. I mean, it would certainly reduce it. Dale, do you know off the top of your head?
I do not.
Okay. Gotcha. All right. And then the only 2 cents that I would add to this, and I mean, so like, I think you have, right. Well, so the general thing in security is always to have the different layers of security. And I think one of the first layers is to eliminate the vast population of your company being able to even interface directly with the clusters and the platform, and instead move towards the Git-driven workflows for all of this stuff, where you have audit trails, you have an approval workflow, you can do linting, you can do policy enforcement, you can do all those things. The second you want to try and create policies for humans, we're in for a world of hurt, and the scale and complexity, the scope rather and complexity of doing this explodes rapidly. So that's what I mean by this is not really the answer you wanted, because, well, this doesn't solve it. Okay, so what do we do about our SREs maybe, or other the personnel who need to access the clusters and do things? For those, different checks and balances. All right. Any other questions?
Yeah, Eric, are there anybody using Helm file in our participants? Have we started using Helm file?
A lot of, yeah, I mean, or how do you say, I mean, we use Helm file every day, all the time, all day long. And I think a lot of folks here now are using Helm file as well. Is there some specific Helm file question you have?
Yeah, the same question. When we use Helm file, so I think there is a way that we can share a file between multiple deployments. I think we haven't started using Helm file, but I heard like there is a possibility that we can share a common environment file.
Yeah. So you can have an environment file and then use that. Basically, when you call Helm file, you specify the environment that you want to use with a flag on the command line. And then that environment file more or less becomes your custom schema, your custom interface to your Helm charts. So the problem, right, with Helm charts is that there is no standardized schema. Every Helm file Helm chart author has their own schema that they come up with. And
Yeah.
it's improving with Helm 3, right? And that you can have was it JSON schema specifications to control it, but it doesn't standardize it anymore than we have today. So when you get to define your own environments in Helm file, you basically get to define your own interface.
Yeah, great, thank you.
Yeah.
Eric, to kind of pull off of that, we followed your code examples to set up Helm file a little bit, and eventually it wasn't working, and then ripped it all out and don't have any Helm file anymore. Sorry.
Okay. That's okay.
Could have been easily fixed probably, but the other reason that we ripped it all out is because we wanted to use Argo to deploy not only our own apps, but also other people's apps. And so we have that all set up in Argo CD to do, I don't know if I could like describe it quickly or pull it up. Nah,
You want to share your screen?
I don't know what's deployed, so I don't have like a demo environment that I can, I have to sort of like look at that, but maybe I could, 1 second. I mean, this is not terrifying.
The one thing I'd say that we are moving away from that we have been doing in Helm file, so we're actively engaged in an engagement in a project right now using Helm file as well. But what we're doing is we're moving away from the copious use of environment variables because of the complexity of managing configuration and code with environment variables. So therefore, we're moving to using environments in Helm file. Basically, long story short, when we started using Helm file, environments didn't exist. Environments came much later, and now we're looking to leverage environments a lot more.
Yeah, which is sort of the answer to that previous question a little bit of how do you get like the basic Helm file to get deployed to stage, prod, dev, etc.
Yeah.
Yeah, I can't share my screen because you're sharing, I guess. But
oh yeah. No, let me stop. There we go.
Desktop to share. Hopefully nothing's terrifying. Can you see my screen?
Yeah.
Yeah. So we. This is what Argo CD looks like. You can sync, refresh. I'm not going to click too much, but you can see we've got a bunch of different stuff being deployed from like one of our own apps, which looks like this, and has like various different processes running in it to like cert manager and like our metrics and these types of things. It's working as expected. We've only put one of our main services into it, the node service, which is arguably a less, like if this goes down, our users won't like be really upset. So we're waiting until we feel comfortable with all of this setup before we put more of our like important services behind it. You will still get a bunch of angry users, but they'll have customer support, and the world won't go on fire. There won't be any New York Times news tests about edX. So like figuring out how to make all of this thread with Argo CD is something that we have made a lot of progress on, but it is a way where we would never use Helm file, and you would use Helm file to deploy a bunch of these things via Helm. instead of the way that Argo CD is deploying it, correct?
Yeah, but we also might have different like ambitions or different like things we want to optimize for.
Sure.
So often an individual company can make some trade-offs that we can't make. An individual company can build kind of a system here for deploying these apps that is highly tailored specifically to your unique requirements of what you want to deploy, and you know what those requirements are today. Sorry, go on.
One of those requirements is so that it's easy for us to maintain it and to grow our team and hire people who know how to maintain it, which the more customized it is, the harder that becomes.
Yeah.
So one of the reasons why we're using Kubernetes itself, for example, is to make it easier to containerize our services in a way that can be maintained by a group of people who we don't have to train from the ground up, because it turns out everybody else is using Kubernetes too, for example. I'd love to be able to follow the same principles with more nuanced aspects of our system, but you're right, we're getting into the weeds of like, okay, we still use this Splunk thing, and Splunk he only supports secrets one way, so we have to do secrets their way in order to get this third-party vendor service running for the Splunk forwarder, I should say.
Yeah, I mean, I hear that all the time, and I am sympathetic to it, and I don't want it to be this hard. I don't want it to be this complicated. I guess we're just still in the early phases of letting this stuff get figured out. Plus, the term best practices is so fleeting in this world because the capabilities are changing faster than the practices can evolve. So making generalized statements on how to do this is a quick way to, bite one's or eat one's words in about 6 months from now.
And we'll change everything 15 times before I wake up in the morning. The Helm file versus Argo thing, I'm sure there's a way where you could use just Argo CD for your own internal applications and Helm file for just your external applications. We're using a combination of Helm charts and customized manifest files around our own applications, in part because of the way Argo CD restricts you. It's not actually doing a Helm deploy, so I can't do rollbacks through Helm. It's doing a Helm, it's expanding it and then applying the manifest files. But the other features you get out of it, I should have clicked through to show like those manifests. You can see the diff between deploys of each manifest file in the UI, which is great for developers to sort of understand different basic Kubernetes pieces. Do you have like an idea from your experiences of where Helm file shines versus where something like Argo CD shines?
Let me show a little bit of both. Also, Alex was kind of asking to see an example of what I was talking about. If we go here to my desktop. All right, so I'm going to go back here to Cloud Posse Helm files and show first, I guess, or let me go here. So arguably one of the most, if we talk about, let's not even talk about Helm or Helm file yet right now. What are the characteristics of systems that have proven massively successful, almost viral in their adoption? Back in the day, we go back to Ruby, and then we had Ruby gems, and it's that ability to have this registry where you can easily download all these gems and get immediate benefit out of it. Moving on to Python, same thing, and then moving on to Docker. Like the idea of containerization existed long before Docker came about, but what Docker did is they combined these concepts, made it bite-sized and easy to consume, and had a registry so that it was highly reusable. Let's step forward to Helm. The reason why I'm also still a big proponent of Helm is that we still need a way to package the knowledge of how to distribute apps which maybe were never designed to run on Kubernetes in a way that we can run them on Kubernetes. And I get all the negative critique of Helm, but I don't see any better alternative that achieves the other things that I just talked about. So like if we have the customize or these other things, I still don't see a registry, so to say, of distributing that know-how outside of your organization. And if that stuff isn't built from day one to live outside of your organization, what we're doing is we're building snowflakes. So go on.
I do want to, so I'm a huge fan of Helm and a proponent of it, especially with Helm 3, with the downfall of Tiller, which we have not ported over to, but will. I specifically was looking at Helm file, like the use of deploying charts through, yeah. Because we don't have any intentions of moving away from, all of our vendors that we pay money to maintain Helm charts. So we're going to use them because that's the easiest way for them and to handle upgrades and whatnot. We're plugging it into Argo CD, which takes away some of the value of Helm, but not any of the things that you just said. But by plugging it into Argo CD in order to get a bunch of other value for our the customize, which we had Helm plus customize, you can glue those two together. They're not exclusive. But
in the way that you're using Helm as a template engine, not as a package manager. And I want to say that these are distinctly different things.
We're still
if I were using Helm strictly as a template engine, I'm less excited about it. But
yeah, I mean, the idea was we would publish our Helm charts so that the world can use them and then deploy them in our cluster our way without Helm deploy.
Yeah, you're totally fair to do. You're totally allowed to do if you want to do that. So, but here, let me just with Helm file, and I brought up the example with Terraform. Why I love Terraform so much, and I think it's been massively successful, is partially because of modules and how easy it is to distribute the knowledge of building infrastructure with modules. Compare that to CloudFormation, which, I mean, it hasn't, in my opinion, in my mind, hasn't had the level of popularity of Terraform, possibly because of the syntax is ugly as sin, but also because of the reusability across organizations to get started. They're doing a little bit more of this, I think, today with CDK, but I can't speak intelligently about that. My point here is then with Helm files, we get the same thing. So with Helm, so what is the problem with Helm? The problem with Helm is every vendor out there gets to define their own schema for how to install and manage that application. Also, sometimes there are additional things that we want to achieve that the Helm chart doesn't do, so we need the escape hatch to be able to do that. That's what we're getting with Helm file is basically this ability that we can just share the knowledge of how to install the Elasticsearch exporter. So all I kind of need to do is this. And then we, as Cloud Posse, define our own schema for how to install this. Okay, I want to pause there for a moment and then say what I'm unhappy, and this is why I'm unhappy with what we have been doing a little bit with Helm files. So we were using environment variables to the extreme, and I'll on a separate office hours talk about kind of my soul searching on that. But let's go and look at one of these guys like KIM, so to say. And in here, this is kind of like the schema that that we need to follow in order to be able to install all the custom CRDs using the raw chart. Then we come down here, and so don't get me wrong, there's a lot of ugly here, but we're still being able to wrap all this this support provided upstream by the Helm chart maintainers. So then our interface has been environment variables, but for aforementioned reasons, I'm less jazzed about using environment variables to the extreme, to the extent we have. And that's why now what we're doing is using the environment files instead. And the environment files are designed to be more digestible by developers or by the users of Helm file. I'm just going to try and pull up an example here if I can quickly. I'm in another window here, so if you don't see what I'm doing, just wait a second. This relates to your question, Alex, on what does this look like. Sorry, I'm still logging into this system here. All right, logged in. Projects, and home files, and EFS provisioning. So this is what it ultimately looks like now when you're using environments. So here's an EFS provisioner. Here's the Helm file. Here's what that looks like. So they've defined their schema. This is upstream what the Helm chart maintainers want. This would be a lot to ask of an ordinary developer to figure out. But by using environments, we reduce this. So this is the configuration file format that we follow, that we use. So this is all that they need to share. This is all that they need to set up and configure. And we can add or subtract from this. We can define defaults. So what we've defined is we've defined our default environment. So these are all the settings that we have by default. And then these are what we override per other environment. So this is what I mean. I like the interface that we're then ultimately able to expose with Helm files. And you might be able to see the parallels between Terraform and Helm file when you architect it this way. So basically, our Helm files become modules for Helm. And our environments are like the variables that you pass in TF-var files in Terraform. But we're doing it in YAML files with Helm file. Is that more clear now, Adam?
Yeah, it's helpful me sort of understand more about how you guys are doing it, and I understand how it was built out. It would be difficult for me to do direct apples to oranges comparison, because we also have 3 clusters and an application deployed to each of the 3 clusters with different values files. As it stands right now, when we update those are Git pushed. And so I think I would have to write like a Jenkins job to monitor for a Helm file change and then automatically deploy it. I would love to like compare that aspect of things a little bit, but
yeah. So in this case here, so in this case here, we've inlined the Helm file, but this could have been a remote Helm file. The reason why we're inlining it here is because we're in transition, moving to this format from our upstream ones that use environment variables.
Right.
So, so what happens here is that we treat this as a mono repo, and then when this repository changes, we're able to apply systematically those changes. And since the configurations are per environment, you said you deploy to multiple clusters. Well, so do we. If you deploy multiple times to multiple clusters, that's not a problem. It's just more environments that you would be defining here.
Right. I think that, so I meant to say that these are good, useful functionalities out of both deployment paradigms.
Mm-hmm.
The custom piece for us, let me think. So when using some Helm charts, we wanted to patch things, and you can't do that easily.
You can't do that easily, yeah.
So you can, which is one of the shines of, and so it's easier for me to compare customized versus Helm or customized draft Helm because I know a lot about those. But the wrapper around Helm using Helm file, I can't speak to as strongly. So I was trying to get a little bit more of the specifics on that Helm file piece.
Yeah, well,
for me, like, go ahead.
Yeah, no, there are, you're right, that there are certain types of things we cannot do with this strategy. Like if we need to change the actual structure of what was generated by the Helm chart, yeah, no go. We can maybe rely on some other third-party things that might inject things in there, like an Istio to inject the pods. But by and large, we haven't needed to do that as much as we've needed to add additional resources. Like oftentimes we need to change the way ingress works. Well, most of the time the authors allow a way to disable the built-in ingress. And then so all we do is we disable the built-in ingress, and then we use things like the raw chart or our mono chart to add all those additional resources we need. So here's a perfect example of we're deploying Cert Manager, right? And Cert Manager doesn't do everything we want it to do. We want to install the CRDs, for example. So here what we have is we're using the Kubernetes raw chart to deploy the each of these CRDs, just defined as inline values.
You know, I remember asking myself, why does the Cloud Posse chart not need to install CRDs separately. And you just answered that question, even though I didn't ask it, which is great. I forgot that I asked that question like a month ago. We're not using your chart right now. We just have a separate manifest file that get deployed after the chart gets deployed to deploy them. But looking at this, I would love to switch over to this piece.
Well, so part of this is also that Helm 2 has limitations that Helm 3 doesn't, and managing CRDs with Helm 2 versus Helm 3 is different. So this, I don't believe we've adapted this strategy to embrace the capabilities of Helm 3, and maybe Cert Manager as well has updated the later releases to support the CRD hooks or whatever they're called in Helm 3.
They didn't when I was looking, but that was now a month ago, so maybe they did.
Yeah.
Yeah. My example that came to mind where I was saying that we wanted to patch something was actually Atlantis, which I know you guys have an AWS ECS Atlantis.
Yeah, we didn't like it. We didn't like running Atlantis in Kubernetes because then you have a God pod that somebody can exec into and do anything.
Yeah, it's pretty terrifying. Hence my security questions that I was just prompted in the beginning of this conversation.
Yeah, hence don't run. You know, like as much as I love Kubernetes and as much as it can run, just because you can't doesn't mean you should. And that's kind of why we went the Fargate. Look, our first V1 of Atlantis was doing it in Kubernetes, and we were successful with that almost immediately. But then I realized, dude, this is scary as all hell that you have a pod sitting there, which is God on AWS, in that account at least, or whatever roles you give that pod to do things. And the fact that Kubernetes out of the box lets you exec into that wasn't sitting well with me.
Yeah, we put it in a dedicated tools cluster, which has a couple different things like the Argo CD and Vault and Atlantis. And it's a cluster that basically doesn't get used by other teams and is properly segmented in some ways. That one tools cluster does have God mode over the rest of our clusters. So it's a great command and control plane if you want to get into that cluster.
What's the hosting, by the way? Hold on, let me, no, I'm kidding.
But and then behind a VPN and et cetera through those aspects. The previous Atlantis version we had was just running on a standalone EC2 instance spun up with Terraform and had like a maybe not super polished playbook, but Ansible playbook. But so this seems like an upgrade in many cases. It's much more HA. We've added a bunch of metrics in the process and got all of our
all the other benefits at the same time, right?
But I started to worry more about the security of our clusters. So we're also improving our security by being scared out
of your mind. Plus, you're streaming all the output from Terraform into your logs, so your RDS passwords and everything are easily shared that way.
We haven't put any passwords into Terraform, which is a pain in the butt. Because it means that there's a few pieces of infrastructure that are not maintained by Terraform in order to get those passwords out. There's a few ways you can mask them and not get them streamed into logs and figure that out. But
like we went down the masking route, but it's like whack-a-mole. There's a lot of things you can't mask out of the box.
Yeah, you can pull it out of like KMS or Vault or do some stuff and try to get it not like have the Terraform do it after the fact, basically. But yeah, thanks for this conversation. It was helpful for me to feel sure.
Yeah, for sure. We didn't get to cover everything today, but this was great. Good conversation, guys. We reached the end of the hour here, so I got to wrap things up. Thank you for joining us today. Here are some things to check out if you're new to Cloud Posse or SuiteOps and what we do. Make sure to sign up to our Slack team if you haven't already. If you're tuning in from like a podcast or other medium, make sure you register for office hours so you can attend these in real time, going to cloudposse.com/office hours. We syndicate these as a podcast, so if you like to consume that way, go ahead to cloudposse.com/podcast and you can subscribe with whatever player you use. Anyways, the recording of this is going to be posted to the Office Hours channel in a little bit automatically, as well as posted to all our social media formats. Thank you, guys. Talk to you next time.
Yeah, thank you.
Thank you, everyone.
Yeah, thank you, everyone.
Yeah, thanks, Kareem.
Thanks, Eric.
Thank you.